Hey there. Now we'll be solving this question that is number of islands, and the question number is 200, and it is from the graph theory Leetcode card. So the question statement is given an M cross and 2D binary grid which represents a map of ones that is referred to as land, zeros as water, return the number of islands. As island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically, you may assume all four edges of the grid are surrounded by water. So now what is this question trying to tell us? Let's see. So they have said that if we have some continuous stretches of one by connecting it four directionally in any direction, we can connect them to form an island. And what does that mean? See, so coming on to this part, if I just zoom it, it will be a better one. If you see, we have got something right here as 1, 1, 1, 1. What can we do? Let's just say we start from here, okay? Let's just say you are positioned right here. What was the value that we had find there? The value that we found here was 1, right? So from here, let's just say we want to go right. Can we go right? Is there an island on right? Yes, we can go there. So I went there. Now again, I'll try to find on to the right as well. I want to go to the right. Is there an island? Yes, there is an island. We go. Similarly, we just continue. Now they have said we can move in any direction from any island, right? And what are the any direction that I'm stating as? It is in the four direction. Okay, left, right, up and down. So now I say that okay, I've reached at this island. I want to go down. Surely you can go down. But now from here, can you go further to the right? Obviously not, because there is no island there. You cannot go to the right as well. You cannot go to the down as well, right? Because there is no island. But here you can see that we can go down. From here we can go right, we can go down, and we can go down here, right? So we can see if we start from a particular island, we could reach these many islands, right? And what do we consider this? This is considered as one island. Okay, so if from one island, if you just can reach similar islands by moving left, right, or down by any path, okay, then that island will be considered as one island. Fine. Now what if we have something like this here? Let's just say the value instead of 0 was 1 here. What would have happened? So we can see that from here we can never reach this part, but when we start from here we can reach here itself, right? If you're starting from here, you're on that island only, so number of islands will be here. What number of islands will be? 2. Why? The first one is here and the second island is here. So even if a value is 1 only, it is considered as an island. Okay, just remember that. So even a single one will be considered a one. It is not like there has to be multiple ones. Okay, it is just meaning that if you can reach number of islands from one island, they are part of the same island. Okay, now let's just say if we have something like 1 1, what can we say? These are the part of same island. Why so? Because we can reach both the islands if we start at any island, right? But we cannot reach to this island right here. So that is why they are separate islands. So this is one island and this is another island. I hope the question is clear now. Now let's get to the part where we actually see the solution and how it's working. So coming on to the solution, what we can do, we can apply a simple DFS or a BFS as well. Okay, and here I'll be doing a DFS one because it was easier to implement. Nothing other than that. Otherwise, you can also do a BFS here, right? Now the prerequisite is always obviously DFS here. Okay, so if you do know DFS, please do continue. Otherwise, please do learn DFS. Just a simple DFS, and then you can continue watching this. Now let's get to the code part on how we are going to do it. Now, before going to the code part as well, I'll try to explain you this on how to approach this problem. At first, what you can say is that you are going to reach every island, right? Why not just start from one island? Okay, then we will start jumping from this island to left or right, to left, right, up and down. Okay, and we will try to go as far as possible. Okay, so this is the intuition. Try to start from one island and try to see how far you can go, and how far we can go. How will be implementing this? We can implement this by DFS. Okay, so now let's get on to the code part. So the code path says that I've just taken an island variable. There is a row and column here, and we are going through each cell. Why we are going through each cell? Let's understand that. See, what did I say? We will try to start from each cell, right? And I'll try to go as far as possible. Like if I start from here, what will I do? I'll try to go as far as I possibly can go. That means I'll try to go here, 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 and here. If I start from here, I'll reach each and every one of them, which has one right here. Okay. Now, what we can see here is that if I've already reached all of these starting from here, now when I start from the second cell, do I need to visit those things again? Just think. Obviously, we don't want to visit them again. Why so? Because we have already visited them from the first cell, na? Or the first island. That is why we do not need to go again from the second cell. These islands have already been visited by some path. Now we do not need to visit again. Okay, so what we will do, we'll just skip. We'll just skip. And ultimately, we'll just end up having only one island with us. Okay, so that is the intuition behind this part right here. That is why we are going through each and every island right here. So basically you start at every junction or every island which is having the value 1. Okay, and it has not been visited by some island. That means, let's just say, if there is a 110 and a 001. So if I start from here, this cell I can visit this, so this will also be visited, but this can never be visited, right? This part will never be visited. So when I come to this cell in my for loop, I will see that it has already been visited by someone. I will not visit this again. Now I'll come to this part, this part, this part, and ultimately when I come to this part, I'll just mark this, and we have two islands left, right? So this is the part which is saying that if we can actually start visiting some islands from this island, go and do a DFS for that and increment my islands by one. Okay, so this is the part where this is done. Now coming on to the DFS part. So this is just a simple DFS with ing saying that okay, I'm present at this cell, or I'm starting from this cell, and the row and column is just the row and column of the grid that we have been given, and I've carried out a visited array and a grid array that we have, and I say that if it has already been visited, no need to visit there again. But if it has not been visited, what do? We just mark it as one. Now you must have seen previously we were going up, down, left, right by calling I minus 1, j minus 1, and all of those things, right? But what can we do better? We can actually create a uh, just iterator of all the directions or path we want to go to. That is, see, at dx and dy at the first index, just consider this. What are we doing? Minus 1 comma 0, we have this value, right? And what does this depict? It just simply depicts that we are going one row up without changing any column, right? We are just going one row up without changing any column. This is what it depicts. And the second one is depicting plus 1 and a 0. Plus 1 and a 0 says what? We are going one row down without changing any column, right? So this is the beauty of this dx and dy that we are having, and we'll be following this through at every time because we do not want to write those statement that is four times, right? Obviously, so that is why I've done this one. That is, I've just iterated from 0 to 4, and I'm saying that new I, my new I, that is my new row will be dx of x plus I, and new j would be dy of x plus j. And I'll just show you this again if it is confusing to you. That is, let's just say I'm coming from 0 0. Okay, I'm starting at the position 0 0. Now what will happen? X is equals to 0. It will say dx of x. Dx of x is what? Minus 1 plus I. So here what will be added? Minus 1 will be added, right? This is the x part. This is the ith coordinate, and these two guys will be added, and what are we going to get? We will get the answer as minus 1, right? Obviously we are going to get minus 1. And coming on to this part, what is this? This is the j where we were starting, and new j will be what? Dy of x plus j. And what is dy of j plus this is 0, right? This is nothing but 0. So what are we going to do? We are going to do dy of x, that is coming to here 0. Sorry, this will be right here, that is 0, and j will be added, that is right here. So what are we going to get? We are going to get simply 0. So our new I and new j will be what? -1 and 0, right? This will be our new I and new j. This is our new coordinate where we are trying to jump. Now we need to see that -1 and 0, is this actually a valid coordinate? We can never go to -1, right? So that is why I've made a function called check boundary, which will say that is this uh, cell that I'm trying to jump onto, is it actually valid? So this is what the check boundary function is doing. Now let's just say this was valid for some reason. Okay, when I try to do it with +1, what will happen? This will be a valid cell because we can obviously jump down and it is well within our range. What we are going to do is, next we are going to check if that row has already been visited. That means when we had something like this, let's just say we had visited something like this, right? We will try to check that is my next row, that is where I'm trying to jump, has that island already been visited? If it is not visited, then I'll go to that island. Got it? So that is what this visited of new I and new j is saying. And also we need to make sure that when I'm jumping to a new row or a new column or wherever I am jumping to, that has to be an island, right? I cannot jump into water. I will always have to jump on an island, obviously. That is what I'm checking here. That is it a island that I'm jumping onto? If it is an island, what do? We just call a DFS by jumping onto that island, and again I'll do this process again and again recursively to get my number of islands that has a connected component. Okay, so this is the whole code part, and if you still have any doubt, please do ask me in the comments. I'll be replying to them as well. Okay, and yeah, this is the whole code. I'll be linking that code link in the description as well if you want the code part. And if you still have any doubt, do ask me in the comment. And if you did understand the explanation and if you're liking the series, please do subscribe. And yeah, thank you for watching.